Welcome to this edition of At Home with APS. Hi, my name is Mrs. Gaudette.
And I am Mrs. Sears.
And we're going to be working today with you for 3 through 5, 3rd, 4th, and 5th grade math. So we're going to go ahead and get us started with a very fun routine that I like called disappearing sequence. And in this one, we're going to be working with fours today in all of the routines that I'm working with you on. So on this one, you have to have the sequence written out. And as we go through, we're going to say the sequence forwards. Then Ms. Sears and I alternating will start taking away the numbers, meaning we're going to scratch them out. That's the best fun of it all.
So I have to remember them?
Yes.
Oh, okay. Better know my sequence. Let me see if I can memorize it really quick.
So doing this, I know a lot of people always ask, why would you do this? Doing this helps us with our multiplication facts and division. So this really is a fun thing to do that will help you in the long run. All right, guys. So let's just go ahead and say it through once, maybe twice, and then we can start disappearing.
So do we alternate?
No, let's just say it together.
Okay. So
unless alternating would be more fun.
I just was asking that question. I wasn't sure. Alternating might be kind of fun, so that might help me remember it a little better if I'm thinking about the numbers.
Or mess me up. All right.
Do you want to count to 3?
All right.
Together?
Yes.
All right. Ready? 1, 2, 3. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. Oh, we're skip counting by 4s.
Yeah.
Ah.
All right, let's do it one more time so we get that sequence in our head good, because once the numbers start disappearing, it's not as simple as you think.
Do we have to scratch out the numbers as we go?
We will scratch them out.
Okay. All right.
Yes.
Just making sure.
Okay. Let's do it again.
Ouch. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48.
So I'm going to ask Miss Sears to go ahead and scratch out the first number that she would like it. Then after we do that, we will say the sequence again, including the scratched out number.
So do I scratch out the first number I see or any number that I want to scratch out?
Any number.
Oh, let's try, I like right in the center here. I'm going to do that one. All right.
All right. So let's say it again. Ready?
4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. Ooh.
So I'm going to get myself this little pointer. Might actually help me instead of going, ah. So it's now my turn to scratch out. Which one would make it the hardest on Miss Sears?
Okay. I won't say.
I'm going to do 2 in a row. Let's see if that can stump us.
Okay.
All right,
We're
here we go.
Counting by 4s. So.
And are you counting with us? I hope you are.
Yeah.
Because this is practice for all of us and something you can do on your own at home or with your parents or with an adult at home.
4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48.
I was just looking at mine. Mine I can see.
Maybe you need a darker color in there.
I'm going to try that again. I don't know if you guys can see it, but I could, and I was like, ah.
It doesn't help, does it? Does mine kind of do that a little bit? Maybe we just need to do it even darker.
Maybe.
All right.
Multiply.
Let's see. Now pick another one. I'm going to go for the end. I'll try to make it nice and dark. Hopefully we won't see it.
All right. Say it with us.
4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. Did we say it right? I think so.
Okay. Whew. Okay.
44, and then 4 more would be 45, 46, 47, 48, right?
Yes.
Okay.
I just wanted to make sure, though.
Nice and dark. Oh, this is kind of in the weird spot. Let's think about this. See, I'm trying to picture them in my head.
Oh, almost like on a board where
Yes.
it's already there in your
Yeah.
head. If you close your eyes, can you picture that board? Picture it.
Okay.
All right. Here we go. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48.
That time I didn't even look. Just picturing it in my head.
Oh.
All right, let's see. Oh, let's do one next to it. Here we go.
You know,
I gotta make a big old square because then I'll kind of know it was a smaller number.
I'm just letting you guys know. Try this and actually try to scratch it out where you can't see. You know how much fun it is just beginning
Yeah.
trying to get it so
Well,
you
I'm
can't see it.
closing my eyes every time that we do this, so I'm trying to remember it.
All right, here we go. 4, 8, 12, 16, 20, 24, 28, 32, 36.
Ooh, that was a hard.
40, 44, 48.
Took me a second there.
I tried to look at you and not look at
Yeah.
it. Because just even looking at it gives you that little clue.
Let's see. Let's try maybe one on the end here. Maybe one of our even numbers or our multiple of 10. I'm getting it really dark.
All right, here we go. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48.
All right.
All right, I'm gonna have to do it. I gotta do it.
Close that gap.
Yeah.
Okay. Let's see.
There we go.
I know you got to point to them, but I'm still trying, like kind of closing my eyes, seeing if I can remember them.
4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48.
Ha-ha. All right. Well, shall we just get rid of the whole row? I'm going to really get it, like I said, make it big. We could probably even put like sticky notes over the top of them if we had to.
You could, except for someone suggested this to me, and you don't know how fulfilling it is just to go
To scratch it out.
Oh,
I can see that.
All right, here we go.
Counting by 4, so I know I got to start by 4.
4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48.
Wow. Okay. It's getting tougher.
Is it my turn?
Oh,
Did you do 4? Wait.
I think you scratched one out. Oh, yes, I did scratch out 4.
Okay, because
You're
I was
right.
going to scratch out 44.
Because I said we were starting with 4. You're scratching out another multiple of 4, by the way.
Oh, look at you.
All right, let's see. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. All right.
Are you guys getting it? Were you starting to come up with these numbers a little easier? I hope so. Keep practicing with us.
All right. Get rid of the multiple of 10 and 4.
All right, here we go. 4,
8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48.
Only 2 more numbers, and then we'll have them completely covered.
I wonder if I can do that all without looking. All right.
All right, here we go.
Okay.
4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48.
All right. Can we do it? Yes, we can.
We got this.
We do. All right.
4,
8,
12, 16, 20, 24, 28, 32, 36, 40, 44, 48.
Woo!
So this is an activity that you could also do going backwards. But instead of going forwards,
I wonder if we could do it
you
backwards.
go backwards. Maybe we'll have to try that next time.
We can try it really quick. I'm just curious.
Well,
Wonder if I could do it.
Let's do one thing of it. 24, 28.
How far are you going to go?
36, 40, 40.
44?
Thank you. 48.
Okay.
So I'm going to scratch off 1. I'll scratch off 12. But do it going backwards.
Okay.
Here we go. Start at 48.
Oh, so maybe I'm going to look at it this time.
48, 44, 40, 36, 32, 28, 24, 20, 16,
12,
8,
4. It was harder going backwards.
You know what? We probably should have practiced that before we did it. So this, again, is a fun activity. Try it on your own. Try it with someone at your house. Just practice.
Put that over here.
Remember, practice does not make perfect. Practice makes
Progress.
All right, guys. So Miss Sears is going to be with you on a task.
Can I move this over here?
Yes, you can.
And will that go fine over there?
Yep.
Okay, perfect. All right, so we're going to do a task right now. This is going to involve addition and subtraction. And as we know, we really want to be practicing our different strategies of how we do addition and subtraction while we are thinking about our problems. And I did actually have something else up here that was kind of a reminder to me. So let me see if I can grab that. And I'll give that back to Miss Gaudette. So when we're thinking about doing word problems, specifically word problems that could be kind of wordy and getting into the context, we want to think about doing what we call STAR. So we're going to search the word problem for clues. That's going to kind of tell us what operation we might be using, which kind of numbers that we're going to be using. We're going to try and translate those words into an equation, and then we're going to answer the problem. And we want to make sure in this answering the problem that we're also very precise about what we're answering. So specifically, if we're talking about a unit that we are counting, for instance, like miles or people, we want to make sure that we include that information along with that and really be precise about naming what it is. And then we always want to go back and kind of check our answer for reasonableness and be able to review the solution, see if it makes sense. Because really, as mathematicians, we really want to make sense of what we're doing in our work. So I have the problem here. Let me get on this side of it. And I'll go ahead and use a little pointer here. So I know many of you might be trying to go on summer vacation and going different places this summer. If you happen to be going out of town somewhere, maybe you might be going to Universal Studios like Lola's family is going to be going. So Lola's family is driving to Universal Studios in California for summer vacation. Sounds like a lot of fun. I'd love to go. The distance to Universal is 880 miles. Okay, is that something that's probably in that searching for clues that we're going to need to pay attention to? In just a minute, we'll annotate, we'll mark the text up to see if those are those things that we're going to need to know in our clues. So the distance to Universal is 880 miles. Before stopping for lunch, Lola's family had driven 355 miles. I don't want to say the and because that's going to mean something different. So they have driven 355 miles. How much further does Lola's family need to go to reach Universal? All right, let's see if we can find some clues here. So Lola's family is driving. They're going to Universal Studios. We know that the distance is 880 miles. 880 miles. They're going to stop for lunch, but before they stop for lunch, they were able to get 355 miles. We need to know how much further do they need to go in order to get to Universal Studios. So let's see, how much further? Maybe I'll circle it. I think I was supposed to underline it, but how much further, that's kind of the question that we're looking to find. So finding those clues, now I've got to translate those words into an equation. So what kind of an equation could I write that would tell me the difference between how much they have gone to how much they still have to go? You got it. Well, let's write that up here on our whiteboard. So we were saying that they had gone 800, or they have to go 880 miles, and they've only gone 355 miles as of the time that they stopped for lunch. So I'm going to go ahead and put that up here. What we're looking for is the difference, the how much further do they need to go. So I'm going to write a question mark for that. Now let's think about this, because the next thing that we're going to need to do is answer that problem. Well, there's a couple of different ways or strategies that we could think about using. One of the strategies that I'm going to be using is I'm going to actually be doing an open number line. Have many of you ever done an open number line when you're trying to solve addition problems, or subtraction problems? I actually use addition to help me solve subtraction problems. I think it's a little bit easier for me to figure it out. I'm going to do that by showing you on an open number line. All right, so here's my open number line, and I know it's not so straight, but I'm not that great at drawing the straight lines here. If I'm thinking about where they started, okay, they'd gone 355 miles so far before they stopped for lunch. How much before they can get to where they need to go? 880 miles. So let's see. So I'm going to think about this as like counting up, because I think so much easier for me to be able to count up from a number and solve a subtraction problem than it is for me to just write it like maybe vertically and up and down and be thinking about like decomposing those different groups of numbers that I have. So if I have 355, what's going to be kind of an easier number that I could get to? Maybe a multiple of 10 that might be easy for me to count. I'm thinking if I added 5 to it, that would give me 360. Okay, once I'm at 360 and I'm thinking about how can I get to maybe the next 100, that multiple that would be an easy number for me to count from, where I could kind of be an easier place to get to. So if I'm at 360, how many more 10s do I need to get to 400? 4 more 10s, or 40, right? So if I add 40 to that 360, I would be at 400. Now, being at 400, would that make it very easy for me to figure out how to get to 880? Probably a little bit. I know I can make a really big jump right here. How could I get to 800 really quick? Yeah, 400 would get me to 800. So if I do 400 plus 400, right, that's 800. And how much more do I need to go to get to 880? Well, 80, yeah. Just a quick hop over there. So now you're kind of wondering, like, what do I do with all these numbers? I just used my open number line to count up to get to that 880 from 355 miles where they first stopped. How am I going to figure out the actual answer? Well, I've got to add all those, right? All right, let's see. I'm going to move this up a little bit. So maybe you can still see that there, but that's going to give us a little bit of more space. And I'm going to switch over here back to my pen. So we know we have 400. I'm just going by the place value right now. We have 40. We have an 80. And we have 5 ones. So let's think about that. Okay, so again, using my place value, I know I'm going to have to add that 40 and that 80 together, which is going to give me, well, 4 plus 8 would be 12, but these are 10s, so I need 12 10s or 120. I'm going to keep that 400, because I know it's 400 plus 120 plus 5 more. If I even broke this down a little bit closer, I could have that 400, make that 120 into a 100 and a 20, if you can see that. And then 5 more. How much do we have total? We have 400 plus 100, 500, plus 20, plus 5, or 525 miles. Yes, remember, we do not want to forget when we're answering that problem, we need to tell and be precise about what unit that we're working on, right? All right, now let me think about, I wonder if I can just erase that whole thing. I want to remember that 525 because I'm going to have to know that, I know, for later. So let's take a look at the next problem. So Evan, who lives right down the street from Miss Lola, and who also, their family is going as well to Universal Studios. And they wanted to drive half the distance and then stop and then keep going, you know, to the rest of the way to Universal. So first of all, we have to figure out how far did they travel, and then what is the difference between how far the Evans family traveled and how far Lola's family traveled. Let's see. Again, we want to make sure we kind of write these clues down, because that's the first thing we're going to search the problem. So Evan's family is also going on a trip. They drove half the distance. We're going to have to know something a little bit more. Okay. So half the distance before they stopped. So how far was it to begin with that we had said? 880 miles. How much would half of that be? Ooh, I think you're already thinking some good ways that we could figure that out. We've got to figure out half of 8, right? Half of that 800 and half of that 80 is going to lead us to that answer. So, and then we need to figure out what is the difference between how far Evan's family traveled and how far Lola's family traveled. All right, so let's do that. Difference between and Evan's family and Lola's family. Okay, so 880. How are we going to figure out half of that? Yeah, if we figure out half of 800, so we know half of 800, if we know half of 8 is 4, right? But we would just have to multiply that by the 100. So we have 400, and then 80, half of 80. 40. It's going to be 400 plus 40. So half of 80, so an equation that we could write the way that Evan's family went. Remember, we had Lola's family that did 880. They went 355 miles, and they had 525 miles left to go. Well, in Evan's family's case, they have an equal addend. Maybe you haven't heard that word before, an addend. So they have equal addends. They went 440 one way, stopped, and then did the other 440 to get there. A little bit different in the equation. So one is using addition, one is using subtraction. What do we got to do now? We got to figure out the difference between how far Evan's family went and how far Lola's family went, right? All right, let me move this up a little bit, see if we can do that. All right, so do you remember what Lola's family did in one day? Yeah, she did 355 miles, right? So who has the bigger number? Who probably went further? Oh, Evan's family went further, so we're going to put that number first. That was 440. And Lola's family went 355. All right, let's do that open number line again. I think that's going to kind of help us and guide us a little bit. All right, let me move that up just a smidge. Okay, so that open number line, remember we start from that 355. We're going to use our addition to help us solve that subtraction. So 355, we want to go to a friendly number. Let's add that 5 back in. That's going to get us to 360. How much further to get to that 400? You probably remember from that before. Yeah, that was 40, right? All right, so now we're at 400. Where did we have to go to? 440, you're absolutely right. All right, so I just need another, well, a smaller hop probably would have worked. I just need another 40 to get to that 440. Okay, now that I've got all these add-ins, I need to figure out what to do to figure out the difference between how far Evan's family traveled that day and how far Lola's family traveled that day. So it's really a question of let's just add these up. So we have a 40 plus 40 plus 5 more. We just know 40 and 40 is 80. We were doing that because that was half of that 80 that we did before. 80 plus 5 more is 85 miles. Yes, I think that you guys did a really good job in reminding me to answer that problem, but we want to be precise. We want to make sure we get that correct. So maybe next time when you're trying to figure out how to get your parents somewhere, you might be able to figure out the distance just by doing something as simple as counting up to help you solve that subtraction problem. Now we're going to have Miss Gaudette come right back, and I think she's going to be reading a book for us.
Yes, everyone, we're going to be reading a really, really fun book. Again, this is a book that I'm going to read, and I'm going to stop during part of it. And we're going to do some little activities that it's suggesting in the book. So the book is Fraction Fun by David A. Adler, illustrated by Nancy Tobin, and published by Holiday House. A fraction is a part of something. We use fractions all the time. When someone says she is 8.5 years old, she is using a fraction. She is saying that she is a fraction, a part of a year, more than 8. Not more than 9, but more than 8, but not 8. When you share a granola bar with a friend, you're using fractions too. Each of you is getting only a fraction, a part of the bar. And then I love this. I'm 21.5 in dog years. Each time you eat a slice of pizza, you are eating a fraction, a part of the pie. Most often, pizza pies are cut into 8 slices, into 8 equal parts. Each slice is one of those 8 equal parts. Each slice is 1/8, 1/8 of a pie. If you eat 1 slice, you're eating 1/8 of a pie. I'd rather have more than that, right? Yeah. If you eat 2 slices, you are eating 2/8 of a pie. You are eating 2 of 8 equal parts. That's looking more my size of pie. In the fraction 1/8, the top number, the 1, is the numerator. The bottom number is the denominator. Each fraction has a numerator and a denominator, a top number and a bottom number. So let's go ahead and let's look at that. So that is actually very good vocabulary that we should remember. So we're going to have a vocabulary chart that we're going to try to keep with us so that you guys can go ahead and be thinking about all the different academic vocabulary we're talking about it and refer back to it. But again, maybe it's a good idea for you to write down your own vocabulary with us so that you have it also, instead of just relying on us. Because sometimes we're not, Miss Sears and I aren't the best at remembering things because we are a little older. So we need your help with some of this stuff. So we have our numerator, our denominator. The book went ahead and told us, and you may have heard this also prior to today at school or from a teacher or from someone else, but remember the numerator is the top number. The denominator is the bottom number of a fraction. So when we talk about numerator and denominators, we're always talking about fractions. All right, so let's get back to that book. Now we're going to be doing some fun pizza pie math. Now let's do some pizza math. It will teach you about fractions. To do pizza math, you will need 3 paper plates, a pencil, a ruler, and a red and green and blue crayons. With the pencil, mark the center of each plate. Using the ruler, draw a straight line through the mark from one edge of the plate to the other. The lines you drew divided each plate in half, 2 equal parts. Each part is a half of the plate. So I'm going to go ahead and read through all of it, and then let's do it together. So if you haven't already done so, run and get some plates and something like that. But we'll have this up online for supplies too. So remember, if today you didn't remember to go online prior to it, go online prior to these, and you can get the supplies so that you have them as you're watching us. If on your plates one part is larger than the other, it is probably because your marks were not in the exact centers of the plates. On one of the plates, write a half in each of the 2 parts. With the red crown, shade in 1 part, half of the plate. On the other plate, draw a second line from one edge of the other and through the center mark. Draw it so that you divide the plate into 4 equal parts, each part being a fourth of the plate. Write 1/4 in each of the 4 parts of the plate with the red crown, shade in 1 part, 1/4 of the plate. On the third plate, draw a second line through the center of the plate, dividing it into 4 equal parts. Next, draw 2 more lines through the center of the plate, dividing it into a total of 8 equal parts. Ooh, that was a tongue twister for some reason. Each part is 1/8 of the plate. Write 1/8 in each of the 8 parts of the plate. With the red crown, shade in 1 part, 1/8 of the plate. So, what they're asking you to do is, I have my plates here. All right. Then what you need is a pencil. I'm just going to use the black. And in the center, as best as you can, go ahead and find that mark. Then you take the ruler and you just draw your line. The reason for the ruler is to make as straight lines as we can. Remember, Miss Sears couldn't make straight lines? On something like this, we want to make as straight lines as we can. Then we were asked to label a half and a half. I'm going to double check. I was supposed to label a half. Yes, a half, a fourth, and then an eighth. Then we were asked to take a red crown and color in 1/2, 1 piece of the pie. All right. So then the next one, we were asked to do a fourth. So we do the same thing. Find the dead center as best as we can. Draw as best as we can a straight line. That's why we have the ruler. But then we have to go the other way to make it. We got to take those halves and cut them in equal pieces. This will give us a fourth, another fourth, and one more, and lastly a fourth. And if we were to have exactly 1/4 of that pie, a pizza pie, we would color in one of them. Now this next one, we're asked to do eighths. So go ahead and draw your dead center, your lines, for just like we did for the half. Then we have the four. Oh, mine was a little off. My center was not good. Now to do that eighth is we would take all the pieces and cut them in half. So you would draw lines directly in the middle of every piece. Ooh, this is too big of a marker now. All right. And then we would label all of them an eighth. And we were asked to color in one slice of that pie. So if I was to do that, I would just color in one of those. All right. That wasn't too hard, was it? Yeah. All right. But now look at the 3 plates. Pretend each of the plates is a pizza pie. Pretend each red section is a slice of pizza. Which slice is the largest? A half, a fourth, or an eighth? Which one would you want? Right? I would want a half. Maybe not, because if I ate a half, I'd be too full. I couldn't do it. Which slice is the smallest? Yeah, the eighth. You notice I keep looking back at my pies. I'm like, What happens to a fraction as the denominator, the bottom number, changes? Let's go back to our pies. Let's look at those. As the denominator, the bottom number, changes, what happens to the slices? Do you see it? Yeah. My bottom number is a 2, which is a small number, but I get the biggest piece. Then if I go down to the 8, which is the largest, what I would think is the largest number, it's actually the smallest slice. Oh, that means in a fraction, the larger the denominator, which is the bottom, the smaller it gets. Oh, that's a big clue to remember. As the denominator gets larger, the fraction gets smaller. As you cut the pie into more and more slices, each slice, pizza slice, gets a smaller and smaller. With the green crown, so you'll need a green crown and a blue one, and I'll have you guys do this as I read it. With the green crown, shade in 2 sections of the 3rd plate, the 1/8. The 2 sections should be next to each other. You have shaded 2/8 of a pie. So next to the red, shade 2 green. With the blue crown, shade in 3 sections of the plate. The 3 sections should be next to each other. You should have shaded in 3/8 of a pie. So the red, the 2 green, and now the 3 blue. If you pretend that the plate is a pizza pie, it's clear that there's more pizza in the blue section than in the green, and more in the green than the red. So 3/8 is more than 2/8 or 1/8. 2/8 is more than 1/8. What happens to a fraction as the numerator, the top number, gets larger? All right, so we can see in there that as you're getting 3, you're getting more of those slices out of the whole. So it's not just one, we're now having multiple of those. As the numerator gets larger, the fraction gets larger. So in this next one, you will need, if you have one at home, you will need a scale that also on this scale, it has to be able to do ounces. Otherwise, you're not going to be able to do it. You will also need pennies, nickels, and dimes. But you could also try quarters if you like. So you're going to need that to be able to do this next activity. Now that you know about fractions, you can find the weight of some things that weigh almost nothing at all. You can find the weight of a penny, a nickel, or a dime, or a quarter. To weigh them, you will need a scale like a diet or postage scale, a scale that can register as little as 1 ounce. You will also need a lot of pennies, nickels, and dimes. How much does a penny weigh? If you put 1 penny on the scale, it seems to weigh nothing at all. Add a penny. Keep adding pennies until the scale registers 1 ounce. How many pennies did it take? Take the pennies off the scale and do the same with the nickels. Take the nickels off the scale and do the same with the dimes. So I'm going to leave you with, from this book, which denomination of coin weighs more? So weigh those pennies, nickels, and dimes and quarters and see which one weighs more. So we're going to move in to with Miss Sears.
We've got a game coming up. And I'm going to actually switch our screen around a little bit so that we're going to be able to see the dice that we're going to need for this game. And can I move this all right? And then you'll need a pen or a marker for this because we're going to be keeping our score. So you need one and I need one. So you need a blank sheet of paper.
Oh, okay.
Move this stuff off to the side. Perfect. Okay. So hopefully, can they see that?
Yes.
There we go. Try to keep that so that you guys can see that. These are going to be the dice that we're going to be using. So the name of this game is called Get to Zero. I'm going to steal a pen over here. I'm going to put my name up here. If you would go ahead, Miss Gaudette, and put your name on your sheet of paper. And we are going to start with the number 999. Okay? So,
Really?
yeah, 999.
Wow,
So,
almost 1,000.
If the object of the game is to get to zero, what do you think we're going to be doing?
Subtracting.
We're going to be subtracting
Yay,
numbers.
subtracting.
Yay! All right. In order to do this, you're going to need to have a partner to play with you. You're also going to need three dice. We went ahead and we just added a cup in there so that we can kind of contain them because I'm a little bit crazy with my dice. So sometimes I might be throwing them off the table. They might be flying everywhere. So I wanted to make sure I contained them. But you could also use a spinner, I guess, if you had a spinner, and any of those numbers that could work on there. But the object is that we're going to roll these three dice, and we're going to see what number comes up. I'm just going to kind of give you a little for instance here. So I rolled this first one, and can you see those? Let me put them out there. So I have a 6, a 2, and a 6. I can arrange those numbers in any manner.
May I just make it so it's a little larger?
Yeah, if you wouldn't mind. Maybe that'll make it a little bit better. And possibly a little bit further out.
Yeah.
I think that's perfect. Can y'all see that? Hopefully you can see that pretty well.
Sorry, it's backwards from what I think it is.
Now it's off the screen, so I think I'm going to put them a little bit further.
Okay.
How's that? All right. So you can arrange those 3 dice into any order that you would like to have them, and you're going to use that number to subtract it from your 999, and the object is to get to 0, okay? Now you might be wondering what's going to happen when I start getting into right now I'm in hundreds. What's going to happen when I start getting into tens, and then I start getting into ones?
Am I going to lose a turn if I can't organize the numbers?
You can roll just 1 or 2 dice. You don't always have to roll the 3 dice,
Okay.
As you get down further into the number, you're going to want to roll either 1 or just the 2 dice, okay? And then if, you're absolutely right, if you cannot get to that number, you can't get exactly to 0, or you can't do anything with the number that you rolled, you lose your turn. Okay? So we're going to start from this 999. I'm going to go ahead and I'm going to roll. I don't get to keep that, although that would be a good number because that would take a lot out. I could make it into the 600s and it would go really quickly. All right, let's see. Can we see these numbers? I'm going to put them over here. All right, so you see I have a 6, I have a 3, and another 3, okay? So arranging that number the best way that I can think of, I'm going to go ahead and do 633. So I can take away 633 from that 999, and now I'm going to have a new number, right? So I can do 9 minus 3, that's going to be 6. This is 90 minus 30, or 60. Ooh, that's kind of a weird number. It's almost like a reverse number of what I had. And then the 900 minus the 600 is going to be 366. All right, do you want me to roll for you? Would that make it easier?
Ahead.
I'll try
You
to.
seem to have more luck.
I'll try to roll you a good one. Oh, I think I just lost my dice. See, this is why I say. Okay. So, I rolled her a better number. She has 6, 6, and a 1. How do you want to arrange them?
All right, so I'm going to arrange it like she did with the largest number first, which is 600. And then the next largest number is a 6, so that's 60, and then the 1. So if I subtract that, I will get 8. 9 minus 6 is 30.
9 minus 6 is 90 minus 60, right?
Yes,
Yeah.
yes. Thank you for correcting me. 900 minus 600 is 300.
Okay. So who still has less to go? She does right now. She's got a little bit more than 20, well, about 28 ahead of me there. All right, so I got to roll good again. Now, what's going to happen if I roll a 6 on this one? I don't want to put it over here in the hundreds place because then I would go negative, right? I wouldn't be getting to 0. I'd be going below 0. So I got to think purposefully, a little bit strategically about how my numbers are going to arrange. Oh, good thing I did.
Move them.
Good thing I did get some numbers that would work really well for me. All right, I have a 3, I have a 1, and I have another 1. So I'm going to go ahead and arrange those sort of greatest to largest, but I know I at least have 300, right? So I'm going to do 311. I seem to be getting very lucky that I'm not having to decompose any of these other numbers right now. So I have a 6 minus 1, so that's going to be 5. I have 60 minus 10, again, another 5. And it's almost like my numbers repeat itself. And then I have 300 minus 300. I'm down in those double digits. So I have 55 to go.
You know, she's pointing out to me already where she's at. We'll get her.
All right. I'll try to roll well for you. All right. We have, let me get one more over there. Can you see him?
Yep.
You have 3, 4, and a 1.
Oh, I can do 300.
I think she might have got me.
314. And I didn't put the 4 first because 4 is bigger than 3, and that would be a negative number, so that didn't help us. And I didn't put it next because, again, we had another 3, so I had to put it last. Luckily, that worked out. So 8 minus 4 is 4. 30 minus 10 is 20. And 300 minus 300 is 0.
All right.
So I'm doing okay.
She's still beating me there. She's only got 24 to go. I have 55 to go. Well, let me ask you something. Am I going to roll those 3 dice this time? No, because I don't want a hundreds number.
Can I roll all 3 dice and just pick the numbers I want?
No.
Oh.
No, you can start to go down once you have different numbers. So let me go ahead and try this. I'm going to roll 2. I'm going to see. Hopefully I get a 5 and a 5. If I get a 5 and a 5, I'm there. I already win this game, right? Let's see. I don't want to jinx myself. I'm going to jinx myself. Oh, I did get a 5.
Oh my gosh,
5 and a 3. I was just thinking it, and it just comes, it manifests itself. You gotta think it, and it will happen, right? So I'm gonna make a 53, okay? So if I have 55, and I'm trying to get as close as I can to 0, right? I have 55 minus 53, so here's this 5 minus 3, that's 2, 50 minus 50, I have 2 left to go. Would you like to have 1 or 2 die?
2.
2, okay.
Do I, wait. Do I have to use both of them if I roll 2? All right, so.
You could roll just 1 if you want to try and go, because what's going to happen is if you roll something that's bigger than a 2 and a 4, and you have no way to put it together,
then I lose my
your
turn. Okay, then I'm going to do 1.
You want to do 1?
Since I have a very low numbers.
Okay.
So I know for sure.
I took a chance and rolled 2, I guess. So you just want to roll.
I'm going to just roll 1.
All right. See, she said 1, and that's what happened. Now I need to roll that for my next one because that's going to get me even closer, right?
Oh my gosh.
See, now I'm risking the fact that I'm going to only roll 1, and I have to either roll a 2, but if I roll anything other than a 2 or a 1, I'm done. I can't do anything. I lose my turn.
Let's make sure she loses her turn.
2. Let's see. I got a 1. Can you see that 1? Yes, I got a 1. I'm still in the game. What's 2 minus 1? It is 1. 1 to go. 1 to go.
1 die, please.
Still one die? Okay, I can do this. All right. Got a 6. Oops, you can't see
All
it.
right.
She got a 6.
All right, so I need to borrow on this one because I can't do 3 minus 6, so I need to borrow from my 10s to get 13 minus 6. So I know that is 7 because my double 6 is 12, so it's 1 more. And then I borrowed 1 from that, so we have our 10. So I have 10. So my total is 17.
Okay.
Did that make sense, or did I totally
You lost me a little bit. So I think what you were saying is you had to borrow a 10 because you said you borrowed 1.
And I didn't show it, and then.
Yeah. Well, let's see. But you can check that. You could say 17 plus 6 would be.
Well, here, let me break it up. So I broke it up. I had a 10. I took just had a 10 there, and I took it plus 13.
Okay.
And then from there, I had to subtract my 6 from that. So I subtracted my 6 from the 13. And then that's where I got my 7 and then my 10.
Okay. That made more sense to me.
Okay.
When I heard you say you borrowed 1, it threw me off. You really
I borrowed 10. Thank you for correcting me.
Yes, thank you. I just wanted to make sure. Okay. I got to roll a 1. If I don't roll a 1, then I lose my turn. And I rolled a 2, of course. I should have gotten that one.
All right.
All right, ready?
Roll for me. What do we get?
You got a 1. See, there was the 1 I needed. A little too late, but.
All right, so if I take 1 away, I get 16.
All right, she's going slowly but surely. Let me see. I'm gonna go a little bit faster now. 4, lost my turn.
All right, so we are actually at the end of our time. So if you can do the disappearing sequence routine, you could find a task and work and just play around with some numbers using open number lines. You could try out all of the activities we said in here. Remember, try that scale, right? And of course,
Play the game.
what was the name of the game again?
Get to 0.
All right,
And
you
I
guys.
got close to 0, so that time it goes to me.
All right, you guys. So have a great afternoon, and thank you so much for joining us on this episode of At Home with APS.
We really appreciate it. You have a good day, mathematicians.